Hello everyone, welcome back. This is the first video presentation, part one of several videos in which we'll talk about USB host to USB CDC-ACM device communication. In my investigation, the USB host will be one of several different microcontroller boards, including an STM32, Arduino ESP32, microcontroller boards, while the CDC-ACM device will be an Arduino or a VNA, vector nectar analyzer. In the interest of time, I'm not going to talk details about USB and CDC-ACM devices and so on. I assume you already know a little bit about that, so I'll just jump into talking about connecting a Nucleo C071RB, which will play the role of a host, and an Arduino Uno, which will play the role of the CDC ACM device. An important note, in case you want to replicate this example, is that you will have to add a jumper right here on this Nucleo board in order to have voltage supply power to the USB bus to the device that will be connected to this board via USB. So we'll look at the USB communication between two microcontroller boards. In this experiment, the Nucleo board, as shown over here, but I'll show you quickly the experimental setup as well, will simply send every 10 seconds this string of characters that came with the example that I used to modify and build on top of this particular experiment. The other microcontroller board, the Arduino Uno, which plays the role of the CDC-ACM device, is programmed to the very simple sketch that will always send every 3 seconds the string of characters Christinel, my first name, but at the same time it also listens and waits for anything that comes from the USB host, and whenever it receives something, it responds with something of the sort Arduino received, and then it places a copy of what it received. So that is basically it. Let me first show you the experimental setup for testing first the Arduino sketch. This is the Arduino Uno that will play the role of the CDC-ACM device connected right now to my laptop. The sketch is really simple. You see here the main loop, which sends every 3 seconds the message Christinel. At the same time, every iteration of this main loop, if I receive something via the serial, I take it and then I'm sending it back with this message Arduino CDC-ACM device received, and then I place what I received. So you see here, for instance, in the serial terminal, every 3 seconds my name being printed. If I, for instance, send something to the Arduino playing the role of the USB host right now, like I say, how are you? I'll send back, you will see it being received by the Arduino, and the code were sent back to me. Now let me connect the Nucleo board, which will play the role of the USB host, and the Arduino to the other USB connection of the Nucleo board to play the role of the ACM, CDC-ACM device. So once again, the Nucleo board will play the role of the host, USB host, and this the USB device. I have here in the STM32 the project that implements the functionality that I just described. It is an example whose link is in the description of this series of video presentations, with all the source files and everything that you need to replicate in a GitHub repository. So I will not go into the details of how this project inside STM32 is put together, but essentially there is here a function that is tied to one of the threads. This is a Microsoft's real-time operating system to implement this. And in this thread, I'm gonna send every 10 seconds, as I said, this user TX buffer that contains a string of characters and message to the CDC-ACM device, and that is just this string of characters: USB X, STM32 host, CDC-ACM, and I'm doing that every essentially 10 seconds or so. So I have already programmed the microcontroller. Let me just open here a terminal, and then observe here in the terminal that I do receive crystal every 3 seconds from the Arduino, while every 10 seconds I'm sending from the Nucleo board the message USB X underscore STM, which is received by the Arduino and echoed sent back to me here. So that is essentially what's happening right now. This sends every 10 seconds, receives every 3 seconds from this guy. And this guy, whatever it receives every 10 seconds, echoes back to the Nucleo board, and all of this communication is being done via the USB. So once again, the test files, everything you need, the entire project for the Nucleo board and the sketch for the Arduino are available on the GitHub repository for this investigation. Alright, so far we've seen an example that used a Nucleo board as the USB host and the Arduino Uno as the CDC-ACM device. In this second example, in this presentation, I'm gonna use instead of a Nucleo board, an Arduino board also as the host, while keeping the other Arduino as the ACM device. In order to be able to have the first Arduino as a USB host, I need to use a USB shield shown over here. One can find it online to buy. So that's necessary for this experiment, and I'm gonna complicate a little bit the functionality of this example in the following sense. The Arduino that is the ACM CDC-ACM device will be in a standby mode and waiting for the command start to be received, and then once that's happening, it is gonna reply with sending 100 hard-coded float numbers in scientific format to the host, and then it's gonna go back into waiting mode again for the command start. At the Arduino host side shown over here, I'm gonna have this functionality like a finite state machine mode, like where the microcontroller will wait to receive a go from the user, that is my laptop. Once that will be received, the microcontroller here, the Arduino host, is gonna send the start command via USB to Arduino 2. That, as I said earlier, will prompt for the device, CDC-ACM device, to send those 100 numbers to the host, where I'm going to receive them and print them. That is basically the functionality of this example. Let me show you Now first, the Arduino CDC-ACM sketch is very simple. I'm gonna wait here for the start. Once I'm gonna get it, I'm gonna send 100 numbers that I have them hard-coded right here, some random numbers stored in a local hard-coded one-dimensional array over here. So if you want to see this happening here locally, I can send a start, and then you'll see here all of those numbers being sent with at the end having a terminating null character that will be used on the host device to identify when the transaction, the communication finished. So, all right, let me now connect the Arduino with the USB shield to my laptop so that I can use it as the USB host, and I will connect the other Arduino as the CDC-ACM device, and I should open the Arduino sketch that plays the role of the USB host, so that we can see that indeed we can send and receive the start command, and then receive the 100 numbers from the other Arduino. So once again, what I'm gonna show you now is this. This Arduino host is gonna wait for me to type on my laptop the keyword or the string go. Once this receives that, it's gonna send the command start to the USB device, which will then be sending 100 numbers back to the host in scientific format. I will receive them here and print them into the serial terminal of the Arduino IDE that is connected to the this USB host. So that's what I'm gonna do. So here is the Arduino sketch that implements that logic. So you'll see here in the main loop, I'm waiting first for the go. Once I type go right here in the serial monitor, you will see that triggered the start command to be sent to the device, which in turn will respond with sending those 100 numbers, which I will be receiving, and this receiving state, I'm expecting 100 of them, and then I'm just gonna process print them right here, listing them as I receive them. So you see here 1.8577, 9.9167, and so on, being exactly the same that I have sent from the other Arduino, where those numbers were hard-coded in this array that was sent one by one. So basically that is this second example. I'm gonna stop here this first part of this series of presentations. In the next one, in part 2, I'm gonna connect this Arduino as a CDC-ACM device to an ESP board. So I'll see you in the second video presentation of this series.